Welcome to our presentation on Ascensionoid, an innovative framework for sustainable technology evolution that was first demonstrated in the Champion project at the 24 OFCA 5G Campus Application Competition. Today, we'll share the technical architecture and implementation insights from this project, adapted to help other organizations understand how they can apply these principles in their own environments. Our focus will be on how Ascensionoid enables existing devices to evolve through cloud AI integration and advanced connectivity. In this presentation, we will explore Ascensionoid, a sustainable approach to IoT device evolution. We'll define the core concept and its foundational principles, showcase its real-world implementation through our campus solution, detail the technical architecture and integration methods, explore its broader applications and impact on future technology development. The Ascensionoid framework demonstrates how legacy devices can transcend their original limitations. By transforming a basic line-following robot, we've established a scalable approach that empowers existing IoT devices with advanced AI capabilities. This implementation shows how cloud integration and connectivity can revitalize existing hardware into smarter, sustainable solutions. In today's rapidly evolving technological landscape, we face critical challenges in sustainable device development. The premature obsolescence of IoT devices, coupled with limited upgrade possibilities and growing AI computational demands, creates both economic and environmental concerns. These challenges call for a new approach that can extend device life cycles while meeting modern performance requirements. Traditional IoT device development faces fundamental limitations that hinder long-term sustainability. Hardware-dependent upgrades, local processing constraints, and fixed functionality create a cycle of premature obsolescence. This rigid approach results in shortened device life cycles and contributes significantly to electronic waste, highlighting the urgent need for a more sustainable solution. Our research centers on 4 key objectives to realize the Ascensionoid concept. First, defining a sustainable framework that enables IoT devices to evolve beyond their initial capabilities. Second, leveraging cloud AI through advanced connectivity to enhance device intelligence without hardware upgrades. Third, enabling continuous functional enhancement through software and connectivity innovations. Finally, establishing scalable upgrade pathways that allow devices to grow with technological advancement. These goals form the foundation for implementing Ascensionoid-based solutions across different domains. The Ascensionoid approach demonstrates how existing devices can be transformed through 3 core elements. Cloud AI integration brings advanced processing capabilities through RAG and LM implementations, while offloading intensive computations to the cloud. Advanced connectivity ensures seamless, real-time data transmission with low latency, essential for cloud-based processing. The Sustainable Evolution Framework enables progressive enhancement of device capabilities while optimizing resource usage. This reference implementation showcases how organizations can apply Ascensionoid principles to extend their IoT device life cycles. The Ascensionoid architecture consists of 3 fundamental layers that work in harmony. The cloud layer serves as the intelligence center, featuring AI processing services enhanced by RAG knowledge integration and LLM dialogue systems. The network layer provides the critical connection through advanced infrastructure, enabling real-time data transmission. At the device level, we optimize local processing while integrating necessary sensors, demonstrating how existing hardware can be enhanced through cloud connectivity. This layered approach provides a flexible foundation for implementing Ascensionoid-based solutions. Here we see a detailed implementation of the Ascensionoid architecture, showcasing how the components interact. The system is crowned by an intelligent collaboration mobile application that provides comprehensive user interfaces. The advanced network layer enables high-speed, low-latency communication, while cloud services handle AI processing, data management, and knowledge retrieval. At the device level, various sensors and modules work together to enable advanced functionality. The RAG command processing flow at the bottom illustrates how the system handles intelligent interactions, from initial request through knowledge retrieval, LLM processing, to final execution. This reference architecture demonstrates one way to realize the Ascensionoid concept while maintaining flexibility for alternative implementations. The integration framework demonstrates how Ascensionoid principles can be implemented in practice. On the cloud services side, we establish AI model deployment pathways, data processing pipelines, and knowledge-based management systems. The connectivity interface handles critical functions like data stream management, service discovery, and resource allocation. This framework serves as a reference implementation, showing how organizations can structure their own Ascensionoid-based solutions while maintaining flexibility for different use cases and requirements. The key technical elements of our implementation showcase two primary functional areas. The Intelligent Processing System combines AI services with RAG knowledge integration and LLM dialogue capabilities, enabling advanced device functionality through cloud processing. The Indoor Position Services demonstrate how existing infrastructure can be leveraged, utilizing RSSI-based positioning, SLAM mapping, and real-time tracking. These elements illustrate practical applications of Ascensionoid principles, showing how device capabilities can be enhanced through cloud AI and connectivity. The unified platform brings together various components into a cohesive system, demonstrating one approach to implementing Ascensionoid concepts. It features a mobile interface for user interaction, real-time monitoring capabilities, task management, event processing, and collaborative communication. This platform architecture shows how different elements can work together while maintaining modularity, allowing organizations to adapt and modify components based on their specific needs. A core principle of Ascensionoid is maximizing device sustainability through intelligent enhancement. Instead of replacing hardware, we demonstrate how existing resources can be leveraged and enhanced. By breaking through local computing limitations via cloud AI integration, devices that were previously constrained by their onboard processing can now perform advanced functions. As shown in these transformation examples, we've extended device life cycles by upgrading capabilities through connectivity rather than replacement. This approach exemplifies how Ascensionoid principles can be applied to reduce electronic waste while enhancing functionality. Our implementation showcases sensor integration with depth cameras, LiDAR, and SLAM positioning, alongside autonomous capabilities for power and charging management. This demonstrates how existing devices can gain advanced functionality through Ascensionoid principles. Our mobile platform integrates multiple key features through a three-layer architecture. The security layer ensures authenticated access, while the smart dashboard provides real-time monitoring and control. Through the 5G and AI integration layer, all functions are seamlessly connected to our cloud services, enabling intelligent and responsive operation. After logging in, users are presented with a comprehensive dashboard that provides instant access to all critical information. This includes event notifications, ongoing task status, Ascensionoid's current location and battery level, as well as recent collaborative conversations. The interface enables quick navigation to detailed function screens through intuitive widget interactions. Our mobile platform simplifies indoor positioning data collection through an integrated approach. Users can collect RSSI signals from 5G base stations and Wi-Fi access points at predefined indoor locations. With one click, this data is automatically processed to update our AI positioning model in real time. Our positioning system features multi-dimensional visualization with floor-level switching and flexible map controls. Users can search for others' locations and track movement in real time, leveraging cloud AI for continuous position updates. The system enables location-based services, from transit task coordination to incident alerts and intelligent service area mapping. The real-time control interface provides high-resolution video streaming with task status monitoring. Administrators can take manual control using the intuitive joystick interface when needed, with SLAM map integration enabling precise navigation. The task management system handles multiple user requests with integrated permission control. Users can flexibly adjust task priorities through drag-and-drop interaction, while monitoring real-time progress updates and planning task sequences. Our event tracking system features a comprehensive workflow from detection to resolution. When AI detects predefined behaviors, it automatically generates an event with contextual data. The system then distributes notifications through multiple channels before assigning to staff for handling. All events are tracked through completion and archived for analysis, ensuring complete incident management. Our event management system streamlines incident handling through intelligent automation and team collaboration. When AI detects significant events, it immediately captures the scene and marks the precise location. Staff can quickly respond through one-click task assignment while maintaining real-time status updates shared across the team. The system provides comprehensive management features, including multi-dimensional filtering and complete event tracking, ensuring efficient incident resolution and historical record maintenance. Our intelligent collaboration hub integrates RAG and LLM technologies to enable natural interaction with the system. The platform processes user queries through our knowledge base, combining real-time data sources with smart command capabilities. This enables automated task execution while maintaining context-aware responses, all supported by our comprehensive team collaboration features. Our intelligent collaboration platform goes beyond standard messaging capabilities. By integrating RAG and LLM hybrid architecture, it enables interactive dialogue with Ascensionoid. Users can request real-time environmental photos, query current observations, access event data, and even command the robot to navigate to specific locations, all through natural conversation. Let's demonstrate an interactive dialogue with Ascensionoid, showcasing how RAG technology matches service areas while LLM processes and executes natural language commands in real time.
你可唔可以過嚟我嘅位置？
Through cloud AI analysis using RAG and LLM, combined with our RSSI positioning service, Ascensionoid intelligently processes and executes the command, demonstrating seamless integration of natural language understanding, location services, and autonomous navigation capabilities. Our behavior detection system integrates advanced depth camera analysis with real-time processing capabilities. The AI models are trained to recognize specific behaviors including falls, running, proximity violations, and uniform compliance, achieving over 90% accuracy across all detection categories. Our innovative indoor positioning system leverages existing wireless infrastructure combined with cloud AI processing. By collecting RSSI signals from cellular base stations and Wi-Fi access points, then processing through our in-database machine learning model, we achieve precise indoor location tracking without additional hardware investment, maintaining accuracy within a 5-meter range. Our Ascensionoid system demonstrates its life-saving potential through autonomous campus patrol and intelligent incident response. By leveraging real-time network communication and cloud AI-driven detection, the system not only identifies emergencies with precision, but also coordinates rapid response by immediately notifying relevant personnel and deploying essential emergency equipment. This achievement transforms existing hardware into an intelligent solution, as illustrated in our following demonstration. Let's witness how Ascensionoid transforms a critical emergency situation into a coordinated rescue response, demonstrating the vital moments that matter most in campus safety.
自主巡邏現在開始。
啊，好忙呀！
請問你係咪需要協助？如果唔係，請你立即調單顯示，否則將會安排當值人員過嚟。請保持冷靜，就安排當值人員過嚟協助。
咦，有事發生喎，就喺樓下，而家我去睇下先。喂，同學，要先啊，寫下啦。
The Ascensionoid platform features advanced autonomous operations, enabling self-directed navigation throughout campus facilities while managing its own power requirements. Its intelligent interaction system allows natural communication between users and the platform, supporting collaborative tasks among multiple stakeholders. In practical deployment, Ascensionoid enhances campus security through intelligent monitoring and rapid incident response. The system optimizes resource utilization by efficiently managing tasks and workloads, while maintaining energy-efficient operations throughout its service cycle. The Ascensionoid framework extends across 4 vital domains: comprehensive community care and safety, focusing on elderly support and public protection; intelligent infrastructure management, enabling smart traffic and space utilization; commercial intelligence, optimizing retail and venue operations; and smart education integration, advancing personalized learning experiences. This extensive application spectrum demonstrates our solution's capability to create safer, smarter, and more connected communities. Our development roadmap focuses on enhancing AI capabilities through advanced learning models and expanded knowledge bases, while strengthening real-time processing capabilities to support more complex scenarios and interactions. Our research priorities include optimizing system efficiency and expanding feature capabilities, with particular focus on collaborative intelligence and advanced positioning technologies. These areas represent key opportunities for academic and industry collaboration. Ascensionoid represents the continuous elevation of existing technologies through advanced networking and cloud AI integration. By leveraging rapidly evolving cloud intelligence and increasing computational power, we extend the capabilities and life cycles of robots and IoT devices. This framework brings new vitality and opportunities across industries, transforming how we approach technological advancement and sustainable innovation.